I'm Hassan Ziade. My colleague is Ezgi Çavaş. For our pre-processing, we did multiple things like remove features, and we restricted our samples, and we added new values for the missing values and imputed some values, and Ezgi will go on explaining those. And for the second part, I'll be explaining the model we selected and why we selected it.
Remove features. Here are all of the removed features. We use the select columns widget in orange. In the ignored section, you can just act as if you have removed the features. The dataset will just ignore them. Restricting our samples. There were some samples that didn't make sense realistically. For example, the base rent or total rent was 0 for some samples. And then there were 9,099 floor values, which also didn't make sense. These all, in my opinion, are outliers, and models don't produce good results when there are outliers present, so we have to take care of them. Using the select rows widget, we have some conditions defined where, of course, since it is supervised learning, we need to have the total rent defined. And floor, for me, realistically, is between -1 and 40 at most. And the year constructed must be at most 2021, which is a year before the current year. Base rent should also be between 50 and 10,000. Total rent should be between 100 and 10,000. And service charge can vary between 0 and 11,000.
So Ezgi, if you
Yes.
go back, so actually I see that you lost 120K samples.
Yes, I at the end I'm showing the like in the end what we have. I also have a screenshot of that as well.
Okay.
Adding new values. Since we had missing values in condition as well, I used the edit domain widget. And we use the edit domain widget. And we have added another value called other here, since we didn't want to assume the conditions of the apartments. It wouldn't be realistic to fill them with the most frequent value. So we just added the other value. And then when it comes to imputing, for categorical values, we have researched that generally the most frequent would be good for categorical values. For service charge, actually, this was our own idea. We wanted to use the model-based imputer, which is a simple tree in orange tree. Heating type is a categorical value, so average or most frequent. Year constructed, we have looked at the years in our data set, and we decided that the average value for year was feasible in terms of realistical data sets. In condition, we have imputed the values to others we created. Type of flats was also average, the most frequent. We also tried averaging the floor variable, but since floor was numerical, we got values like 2.16, which wasn't realistical for a floor. So we reinterpreted the floor value as categorical with edit domain. And then after it was categorical, when we selected the average, most frequent, we all got integers for values, which was feasible. And then we made it back to numerical after our imputations were finished. You can see all the imputations we made.
Ezgi, so
individual attribute settings. Yes?
Ezgi, so you are explaining us how to handle the missing values, am I right?
Yes, so we have no missing values.
Okay, but at the beginning, it would be good if you mention how many missing values in your data or in these columns.
Oh, I'm sorry, I didn't include them.
Yeah, so because without this, taking some actions to handle the missing value is okay, but without the information how many missing values samples in each feature, we are missing very important information about your data set. Do you understand what I mean? Because
Okay.
because in some columns maybe we have missing 5, 6 samples. I am just giving an example. Then you can drop the samples without even you don't need to, for example,
I
imputing.
understand. I didn't include them, but I also tried. We also tried dropping the sample in each value, in each feature before imputing. But dropping, we were dropping many samples.
Okay,
That's why we didn't want to
then
use
it's a
them.
good idea to mention these numbers as
Okay.
well. Okay.
Okay. I
So
will include it in the final report.
yes, please, because
Okay.
it gives us a complete picture of your
Okay.
data set. All right.
Okay.
Let's continue.
In the end, when we are finished, we have 149K instances. We have 15 features, and normally we have 2 meta attributes. There was some kind of a mistake in Orange Tree when we were selecting columns and selecting rows. We accidentally created something, but normally there are 2 meta attributes. Hocam bunu ben de en başta anlamamıştım. Biraz yeni fark ettim kendisinin yarattığını. Biraz beklenmedik bir şeydi o yüzden.
Of course, if you try to convert the dummy categorical values, it will create these titles for yes, no titles. Am I right? Ezgi?
I don't know. It actually doesn't make sense to me because I was just selecting some categories, not creating new ones, but they were here.
But if you select the convert to domain, right, that they will be the dummy, it's called dummy variables in general.
Oh, I understand.
So
I understand.
because if you create the categorical values from some numerical values, that each numerical values will be a label in a new feature, and inside there will be 1, 0 or yes, no kind of things.
Okay, so some of these are dummy values.
Okay, but by the way, you said that there are 15 features, but I see that there are 18.
No, I said we have 18 features plus 5 meta attributes.
Okay, because I thought that you said 15. Okay, let's go to. So you didn't add new features, right? Just meta features.
Yes, we haven't added new features.
Okay, let's go to.
Now Hassan will continue from here.
I'll go on explaining which model we selected and why we selected it. We obviously have a supervised learning model because our inputs and target value are defined. Our target value is continuous. So we went for models that are better for a continuous target value. Like we didn't go for logistic regression or a naive base because they're better for classification, like categorical target values. We tried the linear regression SVM and also the KNN, and we did the train and test, as we'll see in the next slide.
Hassan,
yes,
why not random forest?
I didn't get it.
Why wouldn't you use random forest, for example?
Random forest. Decision trees we are usually also better for classification, but random forest we didn't use it actually. We just tried it on these three. We don't have a specific reason on why we didn't use it, but we just went for like these three: the linear regression, SVM, and KNN.
Okay, Ezgi, do you have an answer for
that? Actually,
because your problem is regression. Am I right?
Yes, and when we checked our linear regression and KNN results, actually they were surprisingly good. That's why we didn't feel the need to add another training model like random forests.
But what is the generic problem with random forest when it is used for a regression problem?
Well, it can overfit way too quickly because it can create too many questions, you know, tree-like structures. And since we have high dimensional...
But you can use the predict techniques for that. And
yes,
linear regression can also easily.
Yes, but it can, random forest can't draw linear lines. That's what you taught us.
Yeah. So, okay, it's a good point because if your data set, if you train your model with this data set and then try to predict new results, you cannot project the prices for the inflation, for example, right? That's the big problem in tree-based algorithms. This is the correct answer I am looking for. But if your prices somehow in real life are fixed, for example, then you can use random forest or decision tree models.
Yes, of course.
Okay, so keep in mind that, okay, your answer should be supported by a argument, right? A valid argument. Okay?
Yes.
Okay.
Okay. Let's go to yes.
For our trained data, we set 70% of the values. Well, usually a general rule of thumb was like 75-25, but when we set it on 75-25, we had just 30K almost for our test data. So we made it 70% for the test and train data. And that's how we split the data set.
Hassan.
Yes, Hajam.
There is some option at the bottom of that screenshot, stratify sample. Do you know what it means?
No, Hajam.
Ezgi?
Hocam, I checked stratify sample. In the internet, it said that it was valid when the outcome was categorical. I read something like that. That's why I didn't check. That's why we didn't check the stratify sample option.
Okay, great. Because you might remember in the class, when I explained these two options, I said that stratify sample means that in train and test data sets, distribution of the classes will be similar with respect to the original data set. Remember? So since yours is your problem is regression problem, you don't need to click this stratify sample. But if it was categorical, then you had to choose this, and so that you guarantee that the distribution of the classes in the train set and the test set would be similar. Okay, for example, 10% cat pictures in train set, there will be 10% cat pictures in the test set as well. That's why we are using stratify. Okay, let's go to you, Hassan.
Okay. Here we can see our trained data. We used, as I said, the KNN SVM in linear regression. Our R-squared values are, as you can see, 99% for the KNN and also 99% for linear regression. But Hojam, on the SVM, we got some like very weird values even on the test data, and we couldn't understand what was going on with it. Like, can you go to the next slide? Also in the SVM on the test data, we just didn't understand what was going on, so we just let it be. But for the KNN and linear regression, also for the R-squared, we got 99% also. So we don't think it was overfitted, and we actually got good results, which also like made us just use these two models.
Could you go back one slide? So what's that result for? Test on trade. Okay.
Yeah,
That's
yeah,
the
this is train and
trade
analysis.
accuracy, trade regression values. So first
Mm-hmm.
of all, did you learn that these metrics, they are varying?
The what matrix?
There are four metrics on that slide or on that screenshot. MAC, RABC, MAE, and R square. Did you
yeah.
learn the meaning of these metrics? Can you
Well,
explain us?
I understand what the R squared is. R squared, it explains the variance or how much of X explains the Y.
Okay, so what is
And the root mean
what's
squared
the
error.
range? What's the range for R square?
The range for R squared is, well, usually we always get it between 0 and 1.
What about SVM R square?
What about the what?
SVM R square result.
I, it was very weird. I didn't understand it, honestly.
I think in your model there is a problem in your model. I think.
Well, we couldn't figure it out. Like, he's usually the one who like explains stuff for us, and so like I couldn't understand what was going on personally. And
Actually, I just wanted to see if the SVM and linear regression would give similar results. I was just curious, but since I don't know very much about SVM, so I can't really
actually,
understand the problem.
SVM is one of a linear methods, right? Just one of the linear methods. That's all. Because you didn't use the kernels, right? You didn't activate the kernel. Am I right?
No, we didn't activate kernel.
Okay.
That's why we get this.
Okay, so it is linear method. When we mention about SVM, we are actually referring to a linear SVM, right?
Yes.
So, instead of looking the MAC, RMAC, and MAE, you can just check R square and you see that there is something strange things happening.
Yes.
So I believe that in your model, you didn't show us the flow of your model. I don't see here, so yet, your model.
I have the orange tree document.
Okay, you can show us later. But here, I think there is something wrong with your SVM. Because R square, we don't expect to be negative 11.
These are all the results without tampering with the models. I mean, they are all at the default.
I understand, but R square is between 0 and 1.
Yes, like I really have no idea why it's like that.
Check your flow, okay, your model.
Okay.
I think there's something wrong. And plus, for the next slide, here you have for the R square again you have some problem. You see that SVM.
Yeah.
And what about the MAC, RMAC, MAE? Which one you would like to use as a performance metric in your problem, Hasan?
As a what, hocam?
As a performance metric, which one you would like to use?
Well, usually we go for the R squared and the root mean squared error.
What do you think that R square is a good metric for you? Because you would like to predict a flat price, right? Or flat rent, actually, right?
Yeah, the rent price.
So the rent is a nominal value, right? Like 5,000 or 500 euros or 500 Turkish liras, right?
Yeah.
By using R square, can you understand the success of your model predicting the rent?
I believe we can, hocam.
Ezgi?
Actually, I think there is still room for root mean error square to be lower than 54.
No, I am not asking the results. I am asking which metric you need to focus on.
Well, actually, I believe the root mean square error should be even lower than it is right now because it seems kind of high to me still.
Actually, the answer, I think, should be mean absolute error. because you are trying to predict a rent. So the rent is a nominal value. Like, as I said, 500 Turkish liras. Now, if you look at 24, you understand that on the average, your predictions are making an error, positive or negative, 24 Turkish liras.
24, yes.
Yes, but
Yeah.
looking R square, RMAC, MAC, they are not nominal values. They are just rooted M square or
I
nonsense. So I
understand.
am asking you, according to your problem, which metric is most important for you? Of course.
Okay, then
So-
mean absolute error, of course.
Do you agree, Ezgi? Do you agree, Hasan?
Yes,
Yes,
yes.
yes, it makes sense.
Especially for the end user, it is important. But as a machine learning engineer, of course, you take care of all of them, and especially R square as well. Because
Yes.
mean absolute error is based on or dependent on the all the values in your data set, right?
Yes.
Yes, true. True, hocam.
But the performance of your model can be monitored by R square, of course, no problem with that. But in the end of the day, when you report to your end user, for a house lord, for example, you could say that, hey, you can rent this house around 1,000 euro, positive, negative 24 euro.
Yes, yes, yes.
Do you follow me?
Yeah, I understand the concept.
So you need to understand these metrics.
So our KNN does a better job than linear regression.
Yes, if you look at it in that perspective. Okay, and in SVM, it is incredibly wrong. I think SVM is just doing random things.
Yes, probably.
Yeah.
So I think you have some problem with SVM module.
We will look into it, hocam.
Okay, let's go to you.
We are kind of done with our presentation. As we said, for our pre-processing, we imputed the values, we restricted some values, we filled up some missing values and removed some, and that's it. We didn't do any more complicated pre-processing because when we did the test and train, we got pretty good results for our R squared. So we just stopped there, and this was our presentation.
Okay, it could be better if you provide us before pre-processing and after pre-processing performance of your models. So we could see that if your pre-processing really work or not.
Okay, sure. We can do that.
Do you understand, Ezgi, what I'm suggesting?
Yes, and our results before pre-processing were like the same as SVM. We got negative R values, negative 10,000 in KNN and linear regression. It was basically the same as SVM. After pre-processing, we got these results.
Okay, but you need to report.
Okay.
It's not only you monitor the result, but you need to share the results. So you need to claim that our pre-processing works positively in prediction. Okay. Lastly, you need to share your flow. I mean the orange model.
Okay, can I just open our flow?
Yes, please.
Okay. Can you see it now?
Yes.
This is our current orange workflow.
So please, can you open the SVM? Double click
yes. I didn't understand any of these, so I just left them like
but you see that you are using kernelized SVM. You click the RBF engine kernel. You need to click the linear.
I should click linear.
Yes, of course. I ask you. Now check the result.
Now it's it's normalized.
Okay, so 5 minutes ago, I asked you that, are you sure that you are using linear SVM? You said yes.
I thought the default was linear. That's why I said that. I didn't know.
So you need to check the defaults as well because you click, not me.
Okay.
Okay, so please be careful. And for the next presentation, I think you need to report all the missing parts of that presentation, plus how to hypertune, find the hyperparameters,
Okay.
find in details, and please compare at each stage. Okay.
Okay
So
hocam.
we did
Okay.
this, we received this, we did this, we gained this. Do you understand? So we should see that if there is any achievement in your fine-tuning hyperparameters or not. All right?
Okay. Okay.
Okay hocam.
Okay. Thank you.